Hello, viewers. In today's session, we are going to discuss an important and conceptual problem from derivatives. And here we are going to solve this problem where we are given a function f of x which is equal to e raised to a maximum of x square comma a fractional part of x for all x belonging to the interval that is 0 comma 1. So here 0 is included and 1 is not included, and we have to find the derivative of f of x at x is equal to half, right? So let us see how we can solve this problem using the concept of maximum of two quantities a and b. So now let us consider two quantities a and b, right? And the maximum of the quantities a and b is defined by this expression, that is half and a plus b plus mod of a minus b, right? So here we'll first simplify or modify this function f of x using this result. So here we have maximum of x square and fractional part of x, right? So here we can write maximum of x square and fractional part of x using this result as half, and then we can take a is equal to x square and b is equal to a fractional part of x. So we have x square plus fractional part of x, substituting the values of a and b in this result, and then we have a mod of x square minus fractional part of x, right? So now we have to simplify this expression, and here we'll make use of the definition of fractional part of x in terms of greatest integer function. So the fractional part of x is defined as x minus greatest integer of x. So we can now write half, and here we have x square, and for fractional part of x we can write x minus greatest integer of x, and then here we have x square minus fractional part of x. So here multiplying fractional part of x by negative sign, we have minus x, and then we have plus greatest integer of x. So now we have here this interval, that is x belonging to the interval 0 comma 1, that is x is greater than or equal to 0 but less than 1, right? So whenever x lies between 0 and 1, then the greatest integer of x is always going to be 0, right? So this is an important step here. So replacing greatest integer of x by 0, we have half, then we can write x square plus x minus 0 plus mod of x square minus x plus 0, and we can now write half x square plus x plus mod of x square minus x. So now to simplify a mod of x square minus x in this interval, let us make use of the definition of mod function. Now the definition of mod function is the mod of p is the positive p whenever p is greater than 0, mod of p is 0 whenever p is equal to 0, and mod of p is negative p whenever p is less than 0. So here we have a mod of x square minus x. So x square minus x can be written as x times x minus 1, right? And now see here x lies between 0 and 1, right? So all the values of x which lies between 0 and 1, it makes this quantity, that is x minus 1, as a negative quantity, right? Because whenever we take x lying between 0 and 1, including 0, then x minus 1 is always going to be a negative quantity, but x is a positive quantity. So here we can write positive times a negative, so this becomes a negative, right? So x square minus x is always going to be less than 0 for all x belonging to this interval, that is 0 comma 1, right? So using this definition of mod function, we can now write mod of x square minus x is equal to a negative of x square minus x whenever x square minus x is less than 0, right? So now replacing mod of x square minus x by a negative of x square minus x, that is minus x square plus x. Now a maximum of x square comma a fractional part of x, it becomes half, and here we have x square plus x, and mod of x square minus x is negative x square plus x, right? So now simplifying it, these two quantities get cancelled and we have half and x plus x. So this is half and x plus x is 2x. 2 and 2 get cancelled and we are left with only x, right? So this quantity, that is maximum of x square comma fractional part of x, is equal to x. So now our function f of x can be defined as e raised to maximum of x square and fractional part of x, which is equal to x. So here we have x for all x belonging to the interval 0 comma 1. So now what we have done here, we have modified this function using the concept of maximum of a comma b, using this result. So we have f of x is equal to e raised to x. So if we differentiate it, then f prime of x is d by dx of e raised to x, and the derivative of e raised to x is e raised to x, and we have to find f prime of x at x is equal to half. So taking x is equal to half in this expression, we have f prime of half is equal to e raised to half, right? Which can also be written as square root of e. So the derivative of f of x at x is equal to half is equal to square root of e.